When people refer to their networks as very functional and very reliable, there's no accident there about some of the work they've done on the back end to make it functional and to make it fault tolerant. That's a fancy way of saying we're building the network with some redundancy so that if a piece of the network fails or has a problem, has a fault, it's able to tolerate that fault and continue forwarding traffic the way we expect it to work. Another way of referring to that would be HA, high availability. And that often involves multiple devices in the background watching each other's backs. So if something fails or if there's a problem, another network device can step in and keep that traffic flowing. Well, in this video, I'd like to chat with you about a concept called FHRP, First Hop Redundancy Protocols, which can help supply some fault tolerance for end users and their default gateways that they use millions of times a day. And let's imagine a scenario at a typical office building where we have a user, and that user, let's go ahead and call that user Bob. And Bob occasionally needs to do some written documentation or written letters and needs to have them sent by an internal courier to a given destination around the city. And so in Bob's office, there are two different people in charge of that. One is named John and the other is named Lou. They're actually in charge of the courier delivery, and they both have separate offices. So we have office 1 and here we have office 2. So Bob has been instructed by his manager that if he ever needs to get a letter or something sent via courier, to go ahead and choose one of these two and just drop off that packet at their office. So let's say we'll go ahead and there's maybe a mail slot for John's office and a mail slot for Lou's office. And what Bob would do is simply go put the message in that box and then rely on John, if he's going here, to go ahead and deliver that. Great. Now here's the tricky part. Because Bob is just dropping off his letters in a slot in each of their doors based on the one he chose, he doesn't know behind the scenes if John's on vacation or Lou is sick or whatever. He is just blindly dropping off that packet at that location and hoping that that message will be sent via the courier service to where it needs to go, out this way. And this scenario is very much like Bob the user sitting at Bob's computer. We'll go ahead and call this PC1, and this is the network 10.16.0.0, and maybe Bob has the IP address of .10, and there is on that network a couple of routers that can help route traffic off the network. But instead of routers being John and Lou, we're going to use R1 and R2. Excuse me, a quick chuckle there. I find that funny. All right, so the challenge is Bob, as he's going to pick one of these routers, how does a computer know or decide on who they're going to use as a gateway? Normally, it's configured, and it's either statically configured on Bob's computer or Bob learned it via DHCP. But either way, Bob is very likely going to have one and only one default gateway. 10.16.0, put gateway here. 10.16.0 and let's use .1 here for R1 and .2 here. And let's pick R1. So we'll use .1 as Bob's default gateway. So Bob is gleefully just sending millions of packets that need to go off the local network here to router 1, hoping that router 1 will forward them in the right direction. Now, here's the bad news. What happens if we have a fault with R1? Either the router blows up or dies or goes down, or this interface goes down, or this interface goes down, for Pete's sake. If there's a problem with R1, Bob won't know anything but to forward packets to his default gateway IP address, and Bob is going to have a diminished experience. It's not going to be as fun because Bob's traffic is no longer leaving the network. So the question may come up, well, how do we solve this? Do we go to all our computers and put in 2 default gateways with a priority order, or what do we do? And one of the best solutions for this is an FHRP. And that stands for the First Hop Redundancy Protocol, FHRP. And the concept would go like this. We'd have 2 routers that are both available on Bob's local network. In this example, we have R1 and R2. Bob's network is the 10.16.0 network, and R1's interface 1/0 is at .1, and R2's 2.0 interface is at .2. And the benefit of FHRP, a First Hop Redundancy Protocol, is that we can create a virtual third router. And we can have a new IP address, a separate IP address just for that, and assign that IP address for Bob to use as his default gateway. So if this represents the virtual router, I'll just put a V there, we can assign an IP address for that virtual router. And let's give it, so .1's taken, .2's taken, let's give it .3. All right, so we give it the IP address of .3, and then we tell Bob's computer that for its default gateway, it should use 10.16.0.3. So because this virtual router doesn't really exist, it's not a physical piece of gear, here's what we do. We just have the 2 routers buddy up. They have a little huddle, and they say, okay, here's what we're going to do. Between you and I, say R1 and R2, we're going to run a protocol where we can support this IP address so that if anybody tries to ARP for it or interact with it, we'll respond. But they decide between them who's going to do it. And with the simplest forms of this redundancy, what they will likely do is one will be the active, maybe R1 takes that role and say, okay, I will do it. If somebody ARPs for or tries to reach .3 as their next hop, I will manage it and its associated unique MAC address. I'll take it over. And what R2 could say is, okay, great, I'll just stand by and let you do it. I'll let you take care and manage all that traffic back and forth with this IP address. But here's what R2 also says. I'm going to keep track of you. I'm going to send little messages and listen to your messages just to make sure you're okay. And if I don't hear from you, if you die, I will go ahead and assume that role. I will go active and I will support this virtual IP address. That is the concept behind FHRP, First Hop Redundancy Protocol. And the benefit is that we can assign a single default gateway for clients to use, and we can have 2 or more routers all working together, cooperating to support that IP address and make sure that packets that are sent to the IP address of .3 and the associated layer 2 MAC address behind it are processed by one of the routers and forwarded outside the local network. So that's the idea behind a first hop redundancy protocol, making that default gateway IP address that clients are using, make it fault tolerant by having 2 or more devices supporting it and being able to forward traffic based on that IP address. Now, to implement this feat of magic, which is pretty cool to do, there are some choices. And some of the choices include Cisco's proprietary HSRP, that's an acronym for Hot Standby Router Protocol. There's an open standard called VRRP. And then there's a third option from Cisco also, which is called GLBP. That's the Gateway Load Balancing Protocol. I hope this has been informative for you, and I'd like to thank you for viewing.